What is location intelligence, and how is it changing the way we solve the problems of the future? Location intelligence uses spatial information to empower understanding, insight, decision-making, and prediction. It has applications everywhere, from retail site selection and solving traffic bottlenecks to maintaining and repairing vital infrastructure. Location-based insights are used in many ways. They can create safer, more efficient supply chains. Growers can trace spoiled crops back to the field from which they were picked. Better understanding the trajectory of hurricanes, tornadoes, and floods can help evacuate residents, reduce damage, and save lives, making cities and citizens more resilient to the increasing severity of storms. Modeling wildfire risks empowers local authorities to clear vegetation and coordinate their response to fires. In farming, precision agriculture measures soil moisture and crop health to deliver water and fertilizer only where needed. Optimizing production costs and maximizing crop yields is necessary to feed another 2 billion people by 2050. Location-intelligent organizations allow all participants to create, manage, and share information, making them smarter, more productive, and more efficient. 2/3 of business executives already use location intelligence to gain a competitive edge. More than half use it to create new market opportunities. For this reason, 97% of companies believe location intelligence is crucial to their success. Most say they plan to invest in location intelligence technologies. We've only just begun to explore the potential of combining spatial information with prediction. Just as we would have once been hard-pressed to imagine all the uses for smartphones, we're still discovering how location intelligence, combined with emerging technologies like artificial intelligence, will uncover new insights and provide a map of the future. Esri, the science of where.
We're in a new age of exploration. In ways it looks like what's come before. Explorers have always been curious, courageous, driven to see the unseen. But today, their tools are more powerful. Discoveries more diverse. And often, what's at stake is nothing less in the future.
One of the big scientific questions this expedition is answering is how climate change in particular is happening in the high mountain regions.
As ecosystems are destroyed, plant species, animal species will disappear. These are shocking things, but it should wake us up. We should be very, very alert now.
National Geographic and Esri have joined forces to inspire students to take on the challenges they will face layer by layer. Announcing Exploring with GIS, a series of video short stories about the power of geography.
Science isn't useful unless it's communicated. GIS turns statistics and numbers into pictures and maps.
Exploring with GIS, stories about a new age of exploration for the next generation.
Today's geospatial and construction services industries are undergoing an astonishing transformation. Our objectives haven't changed, but today's technology is opening up new ideas, new efficiencies, and exciting new possibilities. As clients demand more and more data, we are creating innovative technology-based infrastructure solutions to deliver the critical information they need. And we're doing it faster than ever before, while maintaining industry-leading quality standards. At SAM, we've become America's largest combined geospatial and construction services company for a reason. We've always pushed beyond simply using state-of-the-art technology to deliver services. Instead, we're focused on leading the industry forward, into the future. Every day, we work with our technology partners to make our solutions even more powerful, pushing the newest, most promising ideas out of the lab and into the field. We're also bringing groundbreaking innovation to construction services, taking inspection, quality assurance and control, and program management services to new heights of sophistication and dependability. Our expert teams are delivering the industry's most accurate site data more quickly to a diverse range of projects around the nation. In fact, more than 1.5 petabytes of data flow through our network every day. From transportation, utilities, and energy, to architecture, land development, and federal projects, SAM's technology-enabled insights and high-quality data analysis and hosting are fundamentally improving the way projects are planned, engineered, and delivered. You could say, it's what defines us.
For nearly a decade, GeoPoint has been a leading provider of surveying services. Adopting innovative remote sensing technology such as light detection and ranging, or LiDAR for short, has elevated GeoPoint into a class of its own. LiDAR scanning of electrical transmission lines can save time and money in pre-construction by quickly gathering high-density geo-referenced points and efficiently and accurately creating design surface profiles. A 360-degree field of view ensures data gets collected from the area in focus as well as adjacent peripheral properties, thereby eliminating the need to gain access to private lands outside the right-of-way. Photogrammetry in conjunction with aerial LiDAR scanning results in a final colorized and calibrated point cloud that can identify potential property encroachments, provide an overview of vegetation maintenance, and project a complete model of installed power lines to verify safety clearances and ensure blowout parameters meet regulatory compliance. Now that GeoPoint is on your radar, let's start a conversation.
In 1972, Westwood's founders recognized that the value of relationships, the power of innovation, and commitment to do great work were the ingredients for a successful business. It took a vision, an idea, and some courage to start a company. And over time, turn it into something big. For half a century, we built relationships, came up with new ideas and innovations, and demonstrated our dedication to our work and our clients. We took initiative when it mattered most and found ways to grow and get better at what we do. That's why we are here today. So we turned those principles into our core values, and we live by them. But not just for our sake. At Westwood, we are one team, making a positive difference in the world. Over the next 50 years, we will innovate and find new ways to get people moving, off the ground, across the water, around the world, safely. We will bring shelter from the sun, fresh air, and a place to play. We will carefully create better places to call home, and all that makes a neighborhood function well into the future. We will find new and sustainable ways to brighten your day, calm your nerves, quench your thirst, and keep you safe. We have the power to positively influence the environment of the future and give our children and grandchildren a safe place to call home. And over the next 50 years, we will keep getting better because we know that the work we do at Westwood is much bigger than all of us. We are one team. We are better together, and we will make the world a better place. We are Westwood.
My name is Adam Driggers. I am the Director of Surveying and Scanning Services for Hargrove. We provide laser scanning and surveying services for our clients across our offices here at Hargrove. Our dimensional control team has the expertise to accurately measure and verify that piping and equipment were built to spec, as well as verify fit up in the field for these critical items to ensure turnaround schedules are met.
I'm Marty Smith. I'm a professional land surveyor with Hargrove and commercial UAS pilot. I help execute 3D projects here at Hargrove.
My name is Ty McBurnett. I'm a surveyor here at Hargrove, also a UAS pilot. I spend every day either in the field or in the office gathering or compiling data.
My name is Reed Jones. I'm a land surveyor and UAS pilot at Hargrove. I have a degree in surveying and geomatics. I also studied to become a UAS Part 107 pilot.
Typical scanning job starts with our surveying team meeting with someone from the design team to take us to the site. We meet there, we go and walk the area of concern. We work with the design team to place the scans in a manner that we capture what they need.
Once we plan our missions inside the office, we'll then go to the field.
From that point, we lay everything out. We put targets up, which are surveyed in with our total station. The laser scanner emits a laser beam, and whatever the beam hits collects dimensional data on, so basically getting a point every millimeter. It's safer, faster, and extremely accurate. And we also have drone capability. Our drone pilots are FAA certified pilots.
We utilize the Intel Falcon 8 Plus drone and can be used in electromagnetic environments and the plant environments that we typically work in.
Hargrove has invested in the right tools for the job. I get to put my hands on some really cool technology every day. And it's also really fun.
The drone adds a whole nother level of efficiency and safety to our data capture.
Honestly, we can do what would normally take days or even hours. I can do it in a matter of minutes with a drone.
We utilize our laser scanning and drone capabilities to build a 3D environment for our designers to work in the safety of the office.
Virtual reality experience gives an entirely new perspective on the design and model review. Surveying technology is advancing constantly. At Hargrove, we're trying to stay on the cutting edge.
Hargrove is always looking for a way to team with our clients with the right people, the right place, at the right time, and the right tools.
We've all seen clouds like these and these. But there's another kind of cloud that's impacting your work and your life at this very moment. Whether you've heard of it or not, it's used by millions of people, by 90 of the Fortune 100, dozens of U.S. federal agencies, scores of nonprofits, most national governments, and thousands of state and local agencies around the world. It's Esri's geospatial cloud. More than a network, it's a nervous system, connecting everyone who's making sense of what sensors are sensing, everywhere, every day. It's a geospatial infrastructure that helps you see things before they happen and manage things end to end. It helps answer big questions like when and what to deliver. Should you do this or that? How to plan. How to grow. Generating billions of maps a week, Esri's geospatial cloud helps you to see what others can't. Because when more than 80% of big data is about location, to be data intelligent, you must be geospatially intelligent. Let's see what others can't through the science of where.
Artificial intelligence has been seen as a villain for years in cinema. Our Geographic Information Systems team, or GIS for short, is flipping the script on this classic movie trope. Although known for creating and using mapping software to share information with our clients over the past 20 years, we are quickly becoming known for more than just maps. We heavily participate in researching and developing geospatial technology and are currently harnessing the use of artificial intelligence, specifically object detection and machine learning, to ensure our clients live in a safe, sustainable, and a beautiful community. We have developed new ways to collect useful data. We still use GPS collection, but are able to accompany it with 360-degree imagery or area drone footage for doing photographic inventory. We then take our photographic inventories and use them with other technologies to perform object detection for asset inventory. These technologies allow us to quickly deploy mobile collection techniques and apply object detection strategies for asset inventories. Whether it be identifying street signs or even pavement conditions, data collection is becoming more automated and diverse. Another useful application with artificial intelligence is with traffic operations. Our team is currently using object detection to understand vehicle movements. A combination of tracking algorithms and artificial intelligence can be used to identify traffic patterns by monitoring any traffic video feed. Digital gates are overlaid on key locations of a roadway to identify every vehicle, pedestrian, or bicycle to pass through the gates. A single video becomes the foundation for an intersection or corridor analysis by revealing turning movements or lane count imbalance. As our team continues to use machine learning and the object detection we now use for vehicle identification gets more sophisticated, we are able to better classify vehicle types. Equipped with this information, our traffic engineers have a better understanding of corridors' traffic conditions. The objective in using big data is not the collection, but finding actionable data. It may seem like just a lot of information, but understanding what we're looking for in the data allows our team to gain insights and help achieve goals for our clients. GIS is more than just maps. It's about taking pieces from large data streams and creating actionable data. Our team excels at thinking creatively for data collection, data analysis, and creating solutions for our clients to take their projects to the next level.
How does LiDAR work? Is this the future? How does LiDAR work? Is this the future? Why did Apple decide to introduce it right now? A technology similar to radar, which uses laser instead of radio waves, its principle is quite easy to understand, and now you will see it. Whoa. Do you know when LiDAR was invented, which is now installed on iPhone 12? Its founder is Dave Hall, which created the technology in 2005. It emits a laser pulse to the surface, captures a reflected laser back to the LiDAR source, measures laser travel time, calculates distance from source by formula. This process is repeated by LiDAR tools 1,000,000 times, and the result is a complex map of the surveyed area, known as a three-dimensional point cloud. It all sounds great, but let's understand what it means. The name LiDAR stands for Light Identification, Detection, and Ranging. It is a remote sensing technology that uses a laser pulse to collect measurements that can then be used to create three-dimensional models, maps, objects, and environments. LiDAR radar. They work similarly, but use light waves from laser instead of radio waves. It also makes more accurate 3D models. There are only a few applications that have not benefited from LiDAR, ranging from the gaming industry to Formula One teams. This technology is used for geodetic tasks, construction industry, and environmental programs. There is also an increase in the level of automaton software implementation. This is the dream of any car maker. The main sensor that replaces the eyes of an unmanned car, LiDAR builds a complete landscape picture where the cars, pedestrians, poles, trees on the roadside, and even road pavement defects are visible. So what does Apple use this technology for? The company says that it will help you in three things: photo and video effects, accurate placement of AR objects and scanning objects or rooms. The last two programs can benefit mainly developers and enterprises such as construction, which need to create maps of the premises. For the average consumer, photo and video effects can be an exciting thing. Since LiDAR can work in the dark by removing lasers to calculate distances, Apple uses it for improvement. The company claims that thanks to the sensor, iPhone 12 Pro has 6 times faster autofocus in low light conditions than a regular camera. In addition, the LiDAR sensor allows the device to take the best photos in portrait mode in poor light conditions. This is not a new technology for smartphones, but Apple
scan your
hopes
desk,
that
for
AR
instance,
developers
and all of
support
the
it.
different
A
items on
customer
the
will
desk
accept to
then
pay a
become
few dollars
VR,
more.
and so therefore
Snapchat has already confirmed that it will supply lenses based on LiDAR in its iOS application. We realize that currently this sensor is not of significant importance. It's more like it's a marketing push. Doesn't it look like Face ID on iPhone? Yes, but with a greater operating radius. Face ID also shoots mini infrared lasers, but can only work within a few feet away. Rear sensors of LiDAR work at a distance of up to 5 meters. Why has LiDAR technology appeared on smartphones only now? Because it was during the last couple of years that LiDAR opportunities really were discovered and revealed. When systems became smaller, cheaper, and more accurate, they became viable add-ons to mobile devices that already feature such things as powerful processors and GPS. However, the technology also has great extra potential. Many companies dream of headsets that combine virtual objects with real ones, AR glasses on which Facebook, Snapchat, Microsoft, Magic Leap are working, and most likely Apple will rely on the presence of advanced 3D maps of the world. Also, this technology can change the gaming world. It will not necessarily be Apple. A vivid example is Pokemon Go. Lastly, we can conclude that
Drones are versatile tools that can be used for a wide variety of applications. One of the newer use cases for drones is to help create 3D models, thanks to special software programs that can turn aerial images into digital spatial models. Here's what you need to know about 3D models, how you create 3D models with drones, and how these 3D models are being used across different industries. First, what is a 3D model? It's a three-dimensional representation of an object created by plotting individual points in 3D space along the X, Y, and Z axes. The points are connected by geometric shapes, such as triangles, lines, or curved surfaces, to form the model. You can create a 3D model manually by using 3D modeling software, by using an algorithm, or by scanning a physical object. And this is where drones come in. Drones are essentially airborne scanners that can be used to turn large objects, such as buildings, construction sites, or simply large land areas, into 3D models, thanks to a process called photogrammetry. Photogrammetry is the science of making measurements from photographs, particularly aerial photographs. The way photogrammetry works is it looks at photos of a subject taken from 2 or more locations. It uses the different perspectives of the images, along with the location data of where the images were taken, to triangulate the locations of points on the subject. The more photos you have of your subject taken from different locations, the more accurate this triangulation process will be. The result is accurate point locations plotted in 3D space, which is exactly what you need to create a 3D model. Drone photos are great for this process because every photo is geotagged. This means the latitude, longitude, and altitude from the drone's GPS and onboard sensors are embedded in the metadata of the image. The metadata also includes information about the camera sensor and the optics of the drone. These geotagged photos can be processed by software programs such as Drone Deploy, Pix4D, and others to create 3D models with high detail and accuracy. To get the best results of creating a 3D model with your drone, you need to do two things. First, you need to make sure there is a 60 to 70% overlap between your aerial photos. This helps the triangulation process be more accurate and track the same points between images. Flight apps such as Drone Deploy and Pix4D Capture allow you to create automated flight paths and set your desired image overlap. The second thing you need to do is make sure you capture photos of your subject at different angles and altitudes. Typically, you want to capture straight down images from around 100 to 200 feet. Then you want to circle your subject at a high altitude with about a 30-degree angle. Next, fly at a middle altitude with around a 45-degree angle, and lastly, fly at a lower altitude with a 70-degree angle. You of course also want to adjust your radius to keep the subject in frame. Capturing these different angles and altitudes helps create a higher quality 3D model by providing texture and image data of both the sides of the building and the top of the building. You can then use a software tool to process your images and create your 3D model. You can find more information on creating 3D models with your drone in our article linked in the video description. So how are these detailed 3D models being used across different industries? The construction industry has seen a huge benefit from drone imagery, mapping, and 3D modeling software. Construction firms can monitor progress of their construction sites with regular updates, and they can easily inspect different areas on the site. The accuracy of the 3D models also means they can be used to calculate distance, area, and volume measurements. Land surveying has also seen tremendous benefits from drone technology. Not only has it gotten easier to get an up-to-date view of a landscape, but you can create detailed bare earth models, digital surface models, and true orthomosaics, along with generating 3D models of the terrain. Firms specializing in inspection services can also utilize 3D models and drone mapping technology. They can safely inspect previously unseen angles of properties and equipment more safely and more efficiently. They can spot potential problems with detailed 3D models, add annotations, and see the original imagery for a better look at a particular area. Energy firms benefit from these kinds of tools as well. Much of their equipment is larger, more dangerous, or in challenging to reach locations. The ease of inspecting equipment with drones and 3D models can help make sure inspections happen more frequently, reach more dangerous or challenging to reach locations, and help ensure the safety and longevity of the equipment. The agriculture industry is another area where drones are transforming the landscape. While farmers are not necessarily using 3D models, they can still leverage data from drones to create orthomosaic maps of their fields. Newer drones are available with multispectral cameras, allowing farmers to create normalized difference vegetation indexes for a deeper understanding of their crop health and field performance. Public safety can also utilize 3D models for documenting and recreating crime scenes, recording evidence, and providing a clear picture for investigators, forensics, and jury members. Officials can even gather imagery and data in the wake of natural disasters in areas typically unsafe for people. And finally, architecture and engineering firms are using 3D models to create detailed and realistic context models of their buildings or development projects. These models help architects communicate their final design to key stakeholders and investors. And across all of these industries, drones are making it safer, faster, and more efficient to gather meaningful data while reducing liability and risk. Check out our article linked in the video description for more information on creating 3D models with drones and how these models are being used in different industries. Join our newsletter at a link